Hello everyone, Lance here. It's been a while since I make some simple tutorials, and pretty much all the recent tutorials are pretty hardcore, so I think it's about time I make something a little simpler. So today I'm going to show you how to make this very nice carbon fiber material, procedurally, of course. Now, before we begin, I want to give you a heads up that this tutorial requires some basic knowledge about the math nodes within Blender. And if you are a beginner, then I suggest that you watch some of my previous videos. Those are pretty old, but the principles are pretty much the same. I mean, math is math, right? So I'm going to put the link to the playlist in the description. So please check out those videos before following this one. Okay, with no further ado, let's get started. The first thing to do is just delete the cube and create a plane. Now the carbon fiber texture is a 2D texture, so it requires a UV map, and this plane already have a UV map. So let's switch to the shader editor, and let's get rid of these extra things. Alright, create a new material and call in the UV map. Alright, now by default the UV map will look like this. Alright, but for the purpose of testing the material, I'm going to move the UV map to the center. So create a map node and subtract 0.5 from X and Y. There we go. And I'm going to scale the UV map up a little, like so. Alright, let's move everything back a little. We're going to separate the XYZ. This is the Y channel, and since we don't have the Z channel, we don't use this. Now, create a map node and divide it. Let's create a value node. This value node will be the segment length. There we go. And let's set this to 2 for now. And we're going to multiply this segment length by 2. Like so. And divide this. Divide the x with this value. Alright. And next we will fraction it. Like so. And next we will multiply the fractioned value with this multiply node. Alright, so now the values will go from 0 to 4. And next we will floor this. So now we will have 0, 1, 2, 3, like that. We have 4 segments. Now we will add this with this y value, like so. So as you can see, this operation basically moves the y value down by 1 unit. Alright, let's continue. Now we will divide this with this value again. Like that. And again we will fraction this value. Okay, we have something like this. And now we will compare this with 0.5 to get this mask like this. So we have one texture direction like this, alright, and then we have texture direction like this, okay. And if we set this to, let's say, 4, then the length segment will be 4 unit, like so. And likewise, the horizontal segments will also be 4 units, like so. But usually for carbon fiber, we will use 2, like so. At this point, we have the mask for the alternating carbon fiber directions, alright? The next thing we need to do is to create the actual fibers, alright? So this time we will divide this add node with the original segment length. And again, we will fraction this divide node, and we get something like this. These gradients go from 0 to 1, right? I don't want 0 to 1, I want 0 to 2. Or if the segment length is 3, then I want this to be from 0 to 3, and so on. So let's set this to 2 again. So in order to do that, we simply multiply this with the original segment length, like so. So now we have 0 here, and then transition to 2, and then jump back to 0, and then transition to 2 again, and so on. Alright, so far so good. Let's move on. Basically what we're doing is we are creating the Y channel of the UV of the tiles. Alright, this will be the Y channel of the UV. Now we need to create the X channel of the UV as well. So to do that, we will simply fraction this value. So duplicate this fraction node and connect the X value in there. Okay, and let's move this here. And now we can combine XYZ. This will be X and this will be Y. So as you can see, we have a very nice UV for each of the tile. And if you put this into a texture, let's say the noise texture, you can see we have repeating noise texture for each tile. All right, and this is exactly what we want. So let me just delete this noise and move this up here because we need to create some more data for the carbon fiber. So let's duplicate this, combine XYZ node, and go back to this node, copy this and change this to floor. All right, we have something like this. This shall be the Y channel, and the X channel should be the floor of the original X channel. Just use floor. It will be something like this. All right, and again we will combine the X and Y. We have something like this. Now, so basically this is the position of the cells. So if we put this into a white noise, we get completely random color for each cell, like so. So these two channels are very important later on. Now is a good time to create some node groups. So let's move these back a little, like that. And this segment length as well, move it back and select everything. Okay, Control G to create a node group. And let's go ahead and rename our inputs. There we go. And we should set some limits for the segment length as well. The limits should be 1 and default should be 2. Okay. We also want to prevent this segment length to be lower than 1, so create a maximum node and maximum width 1. All right. So when the number here is smaller than 1, it will be 1 coming out of this value output. And I believe we got the naming wrong. So this should be Y and this should be X. And swap the positions. Now, duplicate this segmentation node and swap the X and Y, like so. So now we have some horizontal cells like this, and let's increase this to 4. So as you can see, by swapping the X and Y channel, we have basically rotate the cells by 90 degrees from vertical to horizontal. All right. And let's go back into this node group, and we need to create some more output. This is the position. There we go. We also need the UV. This up, and we need this mask as well. So connect this mask here. There we go. And finally, I want to output this particular fraction node. So connect this to the group output as well. And this will be our segment factor. Okay. And move this up here. So we have these 4 channels, and we can use these 4 channels to create our carbon fibers. Create a mix node, and we will mix some vectors. This must go to the factor, and first let's mix the UV. Okay, so now we have some very nice UVs going on here. Let me just set this back to 2, and let's try 1. Now let's leave it as 2. So now we can use this as the UV for, let's say, a noise texture, and we can stretch this noise texture using a multiply vector node, and multiply the Y channel with 0.01, like so. And we have some very nice texture going on here. However, as you can see, we have exactly the same noise in every single cell. And in order to break up the repeating cells like that, we just need to add this with the position. So duplicate this mix node, and this time we shall mix the position, and we will add this with this UV. All right, there we go. So as you can see, we have different noise for each of the cells. And if you think that it's not random enough, you can also scale this position by a certain number, and it's going to increase the randomness. And now we can't find any repeating texture at all. And let's increase the size of the noise a little more. Let's say 40. All right. So this will be the microtexture of the carbon fiber, but we still need some height information for the carbon fibers. For example, the curvature along the direction of the fibers, as well as some bevel at the edge. All right. So that's the next thing we want to do. So duplicate this mix node, and this time we will mix the float value instead. Again, connect this mask of the first segmentation node, and this time we will mix up the segmentation factor. The segment factor. And we have something like this. Now we need to turn these one direction gradient into mirroring gradient from the side to the center, like so. And the easiest way to do that is using a color ramp node. Create another key at the exact center, and this key should be white. And set the left and right key to black. Now we have some very nice mirroring gradient, but if we use this to create a bump, it's gonna create a sharp bump like this. We need it to be curved like this, right? And to do that, we can simply use a float curve, and we turn this linear gradient to something like this. So that's the curvature of the carbon fibers. Now, the next thing we need to do is to create some bevels for the fibers. And for this bevel, we're going to be using the X dimension of the UVs. So create a separate XYZ and connect this one over. There we go. Now, again, we're going to turn this gradient into mirroring gradient like this. So we're going to duplicate this color ramp node and drop it onto the wire like so. All right. But this time we're not going to use this float curve. We will use another color ramp node and bring the white key to the left like that. The more we bring it to the left, the sharper the bevel. The thinner the bevel. So I think the bevel should be something like this. And finally, I'm going to combine these two together using a math node. And for this math node, I will use minimum. There we go. So this will be the overall height of the carbon fibers. And this will be the microtexture of the carbon fiber. To combine these, we will simply use a multiply math node, like so. Alright, we're almost there. It's time to create the bump node and connect this to the height. There we go. And the bump is a little too much, so we need to lower this to something small. And let's test it out. It looks nice. Let's bring up the metallic and bring down the roughness, and also set the color to be something darker. Now let me just bring this light down here. I think the light is a little too much, so I'm going to lower the light, the intensity of the light a little. There we go. And I think the bump is a little too much, so let's decrease this to 0.001. We're almost there, but we need to create some color variations for the carbon fibers. And to do that, we will again use this mask, create a mixed color node and connect the mask over like that. And we will use some very dark color like this, and for a color something even darker like that, and connect this to the base color, and let's see. And there we go. Now we have some very nice carbon fibers already, and yeah, I think it's time to create a node group so that we can reuse these carbon fibers later on. So let's move this scale forward and move these two back, and also the segment length back a little, like so. And let's zoom out and select everything except the shader and the three first nodes. All right, Control G to group everything. This is going to be the vector, and this is going to be the segment length. And again, this should be 2, and the mean value should be 1. Let's set this to 50 and also connect it to the group input to create the input for the scale. Here we go. And let's rename this to carbon fiber. Okay, let's go back in and create some more inputs for the carbon fibers. For example, I need to create some inputs for the color as well. So connect these two to the output, the group input, and this will be color 1, and this will be color 2. There we go. And finally, I want to create a scale factor for the depth, the height information. So set this to 1 and connect it to the group input node. This will be z depth. There we go. Now, there is one small problem with this z depth. That is, if we set this scale to something really high, as you can see, the z depth is becoming a little too much, because when the texture becomes very small, the height information should also be reduced. So I'm going to divide this z depth with the scale, like that. And let's increase the z depth a little. Okay, let's increase some more. There we go. And let's see. As you can see, the height information is now consistent with the size of the texture. Alright, finally we need to rename the output. This is going to be the color output. And let's move this above the normal output, like that. Now, there is one thing I forgot about this carbon fiber, is to configure this segment length value. Now let's take a look at the texture itself and set this to 2.5, for example. No, maybe something different. There we go. So we have some errors right here, because this carbon fibers only accept integers. All right, so we need to force this float value into integer, and to do that we simply create a math node and floor it. There we go. And now the error is gone, and we can configure this number to get different textures, like so. Okay, the carbon fiber is basically done. However, at this point, it's not that much better than image textures. And even more, image textures kind of render faster and easier to use. So we basically went through a bunch of troubles of making this carbon fiber node, and we don't get much benefit from it. So we need to improve this a bit to utilize the full power of procedural nodes. So let's go back inside this node and we will extract some information. Let's move this output node here, and let's extract the UV as well as the position, and rename this to UV, and this will be position. There we go. And let's move this back here. Because this is procedural textures, we can actually assign different colors for each thread of the carbon fibers. And to do that, let's create a separate XYZ and connect the position in here. And let's have a look at the X dimension. This X dimension is basically the ID of the thread. So we can use this with a white noise texture, a 1D white noise, and we can create a random value for each thread. And we can now use a mix color, and let's use soft light. There we go. And soft light this with the base color of the carbon fiber. There we go. And let's change the color a bit. Okay. So as you can see, we have a random color for each of the threads within the carbon fibers. And you cannot do this with image textures. All right. As you can see, we have no repetition whatsoever. It doesn't matter how big or how small we want our textures to be. You will never find any repeating pattern. And also, one more advantage of this carbon fiber node is that let's increase this to, let's say, 7. And as you can see, this looks very much like a floor pattern. In fact, you can actually turn this into a floor pattern with some more configuration. So, with some more configuration, I managed to turn this carbon fiber into a floor pattern mask, and then combine that with the wood texture that I created some time ago to create a very nice floor pattern. And by the way, I already made a series about creating this particular wood texture some time ago, and this wood texture is also up for sale on my Gumroad as well as Blender Market store. I'll put the links to the tutorial as well as the store in the video description. Please check those out if you're interested. Alright, the carbon fiber is done, and during the process of this tutorial I used quite a few techniques, and I hope you managed to learn something from this and use the knowledge in your future project. Okay, thanks for watching. I'll see you next time.